Hello friends, welcome to Risingpearl.com. Today we are talking about series 13, in which we are learning surface areas and volumes. This is webisode number 16, and in this webisode we are going to continue to find out how to solve questions that involve volumes of combination of solids. This is part 2, webisode 15. The last webisode was the part 1. So friends, I hope you're following us along at risingpearl.com. Now we have just finished how do we calculate surface areas of combination of solid figures. We spent I think 5 episodes looking at all different kinds of questions involving those. So I hope that if you have not got a chance to take a look at it, please take a look at them. And like we did in the last webisode and this webisode, we are going to focus on how do we solve questions involving volumes, not areas, volumes of combination of solids. So let's continue to look at more questions. Now, like we did in the last webisode, just wanted to highlight, whenever we have a combination of solids, what is the basic difference between areas and volume? Meaning, if you were to calculate area versus if you have to calculate volume of a combination of solids, what is the basic difference? So it's very important to keep this in mind. When calculating area, when we are looking to find out the area of a combination of solid, we do not always add. We do not always add the areas of the parts that make up the solid. And why is that? Because some parts may disappear when we join the parts together. Very, very important, friends. In the last 5 episodes, when we were looking at how to calculate surface areas for combination of solids, over and over and over again we came across examples where we simply did not calculate the total surface area of the parts and just added them. We did not do that. Why? Because of this fact that when you combine the parts, some parts of the area, they disappear. So we have to be aware that which parts disappear and we ignore those areas when we are looking to find total surface area. Now this is true when it comes to finding area of a combination of solids. Now what about the volume? Now when calculating volume of combination of solids, we always add the volumes of the parts that make up the solid. Now I should qualify this by saying we should say almost. We almost always add. So this actually is here. We almost always add volumes of the parts that make up the solid. Now I'll give you like 1 or 2 examples why we do not 100% always add, but we almost always add. This is very, very important. Let's give it like 3 star, each star representing very, very, very important. So again, just to quickly keep this in mind, whenever we are combining solids to make a complex solid, the difference between calculating areas and volume is that when you're looking to find out areas, we do not always just add all of them because some parts, they disappear. So we have to be mindful of those and not consider them. But when we are calculating volume, we almost always add the volumes of the parts that make up the solid. Let's take a look at some more questions. Ria, an engineering student, was asked to make a model shaped like a cylinder with 2 cones attached at its 2 ends by using a thin aluminium sheet. So this is the model which is going to be the solid that we need to figure out, right? And the description of the model follows. So it has a cylinder, there is one cylinder with 2 cones attached at its 2 ends. That means you should be able to, by just looking at this particular information, you should be able to visualize how your model should look like. You have a cylinder and you have 2 cones attached on 2 ends, right? The diameter of the model, now some information is given to us. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, height of each cone is given, find the volume of air contained in the model that Ria made. So we have to find out volume. This is a volume question. Volume of air contained in the model that Ria made. Assume the outer inner dimensions of model to be nearly the same. So whenever you read a question like this, so first thing is we have to figure out how the model should look like. So we start with a cylinder and we have two cones on two ends of the cylinder. We bring them one by one and this is how our model should look like. Now also it is important to understand that instead of having our model look standing up or vertical position, right, our model can also look like this. That is, it is actually lying down or it is in a horizontal position. So it does not matter whether you think the model, let's call this A and this is B. It does not matter that if the model actually looks like A or it looks like B, they are the same when it comes to the volume of air which is contained inside it, right? So, but it is important for you to make sure that your model, that when you actually draw the shape, that you have one of these two as the shape of the model or the solid. There is a cylinder in the middle and there are two cones on two ends. There is a cylinder in the middle, there are two cones on two ends. So now, how do we find out the volume? So very simply, we will assume the position 1, which is the model is standing up. The volume of air, which is inside the model, will be simply equal to volume of the top cone plus volume of the cylinder plus the volume of the bottom cone. So we will calculate this volume, say it is V1. We will calculate this volume, it is V2, and we will calculate this volume, which is V3. So we are going to say the final answer will be V1 plus V2 plus V3. That is why I mentioned that the difference between calculating the total volume and total area is different, because when it comes to volume, we will simply find out the amount of air in the cone, then we will find out amount of air in the cylinder, and then we will find out amount of air in this cone and add them. That will give us the total amount of air inside this model. Now very quickly, I know this is a question about volume and not about the area, but if you were to ask, if you were asked what is the total surface area of this, what you would have done, you would have taken the curved surface area of this cone, you would have ignored the area of the bottom circle. Then you would have taken, let's just write it this way, curved surface area of the cone. Then you would have taken the curved surface area, CSA, the curved surface area of the cylinder. You would have ignored the top and the bottom circle of the area of the top and bottom circle of the cylinder. And similarly, you would have taken the curved surface area of the cone below to find out the total surface area. So you would have eliminated the area which is the bottom of the cone and the top of the top circle of the cylinder. Similarly, the bottom circle of the cylinder or the bottom of the cone. You would have eliminated this area. Why? Because when you create a figure like this area actually disappears inside, right? So again, this is a volume question. So when we are calculating the volume, we simply calculate the volume of each of these solids and just add them together, right? So now let's actually see if we can clean this up a little bit. So what is the volume of the top cone? Now let's just take a look at what is given to us. So what is given is that the diameter of the model is 3 centimeter. That means that this is R. So 2R is the diameter, equal to the diameter, and this is given as 3. That means from here we can find out R is equal to 3 by 2 or it is equal to 1.5. So we know the R. So this R is the same as this R, right? And its length is 12 centimeter. The diameter of the model is 3 centimeter and the length of the model is 12 centimeter. What is the length of the model? So length of the model goes from here to here. So now this is the height of the cylinder, but this total length, that is this length plus this length plus this length, the total length is given as 12 centimeter. If each cone has a height of 2 centimeters, so this is 2 centimeter and this is 2 centimeter. So 2 centimeter plus 2 centimeter, 4 centimeter, and if the total is 12 centimeter, that means the middle one is 8 centimeter. So that means, so 2 plus 8, 10 plus 2, 12. So what we know, friends, is that we know the radius of the cylinder and the cone, and we know the height of the cone, height of the cylinder, and height of the cone. So we can pretty much find out everything that we need to find out. So the volume of the top cone, now we know the formula for finding out volume is 1/3 pi r square h, right? Or it will be 1/3 times pi r square. R is this, right? Actually, you can make it let's do 1.5, that's fine. 1.5 square times h is the height of the cone. Remember, we are doing the top cone. So h is 2. So you will actually be able to find out what is this value, V1. And again, we want to keep it in terms of pi. And when we finally add all the three volumes, we want to actually put pi as 22/7 or 3.14, right? So if you just simply calculate, you can find out the volume V1. Now similarly, we can find out the volume of the cylinder. The formula for finding out volume of a cylinder is pi r square h. This gives us the volume of the cylinder, and we know that r is the radius which is given to us, and this is the height of the cylinder, which is 8 centimeter, and r is given as 3/2 or 1.5 centimeter. So we can simply plug the value in here, and we can say this is pi times 1.5 square times h is 8 centimeter. So it will be this much centimeter cube. So if we say this is V2, right? And now similarly we can say, so the total volume is V1, which is the volume of the top cone, and we did not do the bottom cone separately because the volume of the top cone is the same as the volume of the bottom cone, right? Because they both have same radius. They both have same radius and they both have the same height, which is 2 centimeter. So both of them, the volume will be the same, right? So if you simply plug the values in, V1 plus V2 plus V1, because the bottom volume of the bottom cone will be same as V1, so it will be 2 times V1 plus V2. And at this point you want to replace the pi as either 22/7 or 3.14. Normally it may be given in the question itself that use pi as 22/7 or 3.14, but at this point when you are simplifying this, you want to actually put the value of pi whichever way you want and find out the answer. So friends, this was one question where we looked at how first we have to visualize how our solid should look like, and then volume simply means that you add the volume of the individual components and then just add them to find out the total volume of the solid.